Okay, so what you can see here is the IPU compartment with the MDM, the super caps and everything removed. This rat's nest here is obviously my project car harness with interceptors and all. You just ignore all that. I haven't installed the ECM fully yet. I shall do that in due course, so I'm not worried about errors on the dash at the moment. However, this is the installation we're interested in. So as you can see here, what we have is the 3-phase wires from the motor coming in. I've insulated those with some conduit and some tape, and the wires are bolted to the input wires to the rectifier here, and the rectifier obviously goes into the back of the power supply there. And the output, these are the normal 12 volt DC output wires that go to the front of the car, to the battery, etc., and they are connected. So basically it's quite nice and small, nice and neat. Now my motor has had a lot of abuse over the years, extra current, etc, etc, so I think the magnets are a bit weaker than the standard. So anyway, when it's ticking over, the motor outputs about 50 volts, which is quite a lot lower than I anticipated. But the supply can operate at that level. What happens is when you start the engine and rev it up very briefly initially, the DC to DC kicks in, or the power supply kicks in, and then if the motor slowly declines to tick over, then it will support the base load, which is just without the lights on, etc, at tick over. As soon as you start revving it, then obviously it can support, or as soon as you start running it, then it can support lights and all the other stuff up to its current capability. But at just less than 1,000 revs or whatever it ticks over at, the motor output voltage is pretty low. But it can support the base load, and when I was revving the motor to the red line, to the rev limiter, the motor voltage actually rises to nearly 320 volts on my car. So that's pretty high, so it's a good job it's got some high voltage capacitors in the PSU. So basically at the moment it works. I'm going to go out for a test drive in a minute and see how we get on. I've adjusted my OBD CNC to display the system voltage. I need to actually add the ELD current being consumed parameter to it as well, just so I can monitor both of those. I have had my current clamp on the output leads and the voltmeter on the input leads into the PSU, which is how I've determined the voltage, etc. So yes, it works at the moment. I'll just have to see how it works in practice. Obviously if you're going to follow this, you're going to be wanting to get the 12 volt. This is the 15 volt supply, the 12 volt supply, which has a bit more current capability, and to get a few more volts out of the system, it may be that the best way forward is to bypass the bridge rectifier in the PSU to avoid that slight voltage drop. But as I said before, my motor has been abused with high currents over the years, so the magnets may be weaker than normal. I can't confirm that obviously without somebody else trying it. But anyway, it certainly looks like it's got potential at the moment, so while I'm doing my supercapacitor hybrid conversion, this is going to have to keep me running for the time being. Now obviously if you're doing this sort of conversion, your 12 volt battery must be absolutely tip top, because that will have to supply some of the load, especially if you're ticking over with lights on, etc, and heater and all that going. But as soon as you start going along, then obviously the DC to DC can take the load. So you just got to be aware of that, and the earths obviously at the front need to be spot on, because you're going to be using the 12 volt backup starter all the time. Anyway, that's where we are. Quite neat. Phase wires from the motor into the rectifier, into the power supply, out of the power supply at the other end, straight to the car 12 volt battery at the front. Now the supply switches on and off, so obviously as soon as you turn the car on, obviously it's not doing anything. As soon as the motor starts and revs up above about 1500 RPM, then the DC to DC supply, the PSU turns on, and then it'll settle and supply the base load, as I mentioned, down to minimum engine tick over. And obviously as you then start revving and using the vehicle, then the current load can go up, and the DC supply, or the power supply capability, goes up as well. So there we are. Hopefully this is useful. I'll report on the ECM folder once I've installed that later.